Okay, so we have the 3.3 lines pre-class notes. Not very long, just 2 pages. Learn how to recognize a linear equation in 2 variables and then find the slope of the line. Everything else we will do in class. So one of the basic concepts in geometry is that of a line, and we will talk about lines that are just in an x and y axis coordinate plane. So we're going to be using algebra and geometry essentially together. If we have a line, we should be able to pull the equation off of the picture. And if we give an equation, we should be able to sketch the graph. And we also will have a third piece of this, which is I'll give you conditions, and then we should be able to write the equation from those. The main formula that you'll need to know for the pre-notes, and it will be something that you need to memorize for the test, is the slope formula. This is if you have 2 ordered pairs and you want to know what the slope of the line is. We call this the rise over the run. Most people will recognize that. It's how much did the y change over how much did the x change. And it is important, y's have to rise. Okay, they have to go on top. Otherwise your slope will be upside down every single time. So these are just pictures of negative slopes with the pink and positive slopes with the blue. Notice the negative ones are going downhill, positives are going uphill. And you can see the bigger the number, the steeper the slope. Fractional slopes that are small, like 1/5, are really not that steep. But 5/1 is very steep. Okay, so we're going to jump right in and do some examples using our formula. So I'm going to label this x1, y1. That means they came from the first ordered pair. x2, y2, and I'm wanting to find slope. Oops, I don't know why that jumped. So we're going to be doing m equals, and this would be y2 is 6 minus -1 for y1. So you are writing a minus a negative here because the formula requires you write subtraction in the middle. And then on the bottom we have 5 minus 5. Minus a negative would be plus, so that's actually 6 plus 1 over 5 minus 5. So that is 7 over 0. Now, we do not allow you to divide by 0, so anytime that happens, you cannot leave the answer like that. You must write or tell me that the slope is undefined. So we can't do that. This one, we would have m equals -3 is the y2 minus -1 for the y1. The x2 is -6 minus the x1, which is just 4. That makes this -3 plus 1 over -6 minus 4. So that is -2 over -10. And you do want to reduce the slope. Negative over negative makes a positive, and 2 and 10 are both divisible by 2. So we get positive 1/5. And then as a final one to try, -2 minus -2 on top over -3 minus 4 on the bottom. That is -2 plus 2 over -3 minus 4. That is 0 over -7. It is okay for 0 to be in top of a fraction. In fact, if you have 0 on top, the answer is just 0, and you do have to write that. You cannot leave it as a fraction. Otherwise, I don't know if you know the difference between undefined and 0. Undefined and 0 are 2 special cases. They have to do with these two. A horizontal line has slope of 0, and a vertical line has undefined slope. So notice that this is the equation, and it's kind of backwards to people. Horizontal lines have the equation y equals a number, so they look like this. Vertical, and that's because they cross the y-axis only. Vertical lines have to cut through the x-axis, so they have x and just a number. Anytime you have both x and y, you are not dealing with a vertical or horizontal line. They have to be just a single variable. Okay, let's graph this group, and then we'll be done with this section of notes. Told you it was pretty short in this piece because most of it we will do in class. I don't know if I can erase that. Let me see. Let's go to ink. Yes. That M popped down there. Okay, so if we want to graph these, one way to do that, if you don't know about slope-intercept form yet, is to use a table of values. So I'll just do a different color for each one, and we'll graph them all in the same picture. And we'll use blue for this last one. So we're going to do a table values of each. And since I've got blue right now, we'll go ahead and start here. People get really scared when there's a fraction in front. Just pick numbers that are divisible by the denominator and it'll work out pretty okay as long as this is not a fraction. So if you're only dealing with a fraction connected to x, you can do them pretty simply. So I'm only going to use 3 points. You only need 3 points to draw a line, so I'm going to do -2, 0, and 2. Half of -2 would be -1, and then +3 would be +2. Half of 0 would be 0, +3 would just be 3. Half of 2 would be 1, +3 would be 4. So if we plot this one, -2, 2, 0, 3, and 2, 4, and then remember this would be a line that goes through that. Let's move back to our red. Let's again try -2, 0, and 2. We don't need them because of the fractions not being here, but let's just see what happens. -2 times -2 would be +4, plus 3 more would be 7. -2 times 0 would be 0, plus 3 would be 3. -2 times 2 would be -4, plus 3 would be -1. So -2, +7, 0, 3, and 2, -1. Notice this one is a negative slope going a different direction. Positive slope, negative slope. It's different directions, okay? And in fact, something you would note here is that if you had a compass or a protractor to measure this, this is 90 degrees. These two lines are actually perpendicular to each other. And then let's do this last one. So let's again do -2, 0, and 2. -2 times -2 is +4. -1 would be 3. Anything times 0 is 0. -1 would just be -1. 2 times -2 would be -4. -1 would be -5. So -2, 3, 0, -1, and 2, -5. So note this one is parallel to the red one, but also perpendicular to the blue one. So we'll talk more about these relationships and about something called the slope, which we'll talk about slope-intercept form, and how these numbers told us before we ever graphed them that that relationship was going to happen. So that'll be a discussion for class time. So that's the end of 3.3.